Hi, good afternoon. My name is Oyun Shet and I'm an information security analyst at ISOAH Data Securities Pvt. Limited. Uh, Today we will have a session regarding networking fundamentals, IP and MAC address. So why are we conducting this session? What is the difference between our session and other sessions that are available on internet? First of all, we have gathered uh, various topics of regarding the network fundamentals, and try we will try to make you understand the concepts of IP and MAC addresses in such a way that you will gain a profound knowledge when you will be working in the field of cybersecurity or in networking. You will feel really confident when you will be working in these particular fields. Besides that, you will feel confident when you will appear in an interview in regarding these fields. Okay, so we have gathered various topics related to networking fundamentals, like networking devices, and then what actually networking is. Okay, so maybe you will get these ideas from the internet, but all these ideas are scattered in the internet. We have gathered it. We have we have made this session in such a way that you will get everything in this particular session. You do not need to go anywhere else if you join and watch our session. Okay, all right. So now, what we will be going to do today? First of all, as we can see that the name the session is all about networking fundamentals. Okay, and in that networking fundamentals, IP and MAC addresses are included. Okay, when we are going to talk about networking fundamentals, then we should include IP and MAC addresses, because these are the integrated parts of networking. All right, so now let me discuss what is a networking. Okay, just let me let me keep it simple as of now. Okay, because I need to go from the basic to advanced. Okay, so first let's understand what is networking. So what networking is? Networking means when when two computers or two computing devices are interconnected to each other. Okay, when two devices are interconnected to each other, for what purpose? They are interconnected for some reasons, right? So they are interconnected for sharing resources, for sharing data. Okay, so this is called a network. This is a very small network. When only two computing devices are connected, this is a very small network. And if we make it, in a large scale, then we can consider it as an internet. That, I mean, we look, we, I mean, get acquainted with this word internet every day, but we don't know properly what internet is. Internet is nothing but network of interconnected computing devices. Every computing device is connected to each other, whether it is by using a wire or wirelessly. Okay, every device is connecting to each other. Without any connection, we can't communicate with a device. So in networking, connection should be there. Okay, so this is the basic definition of networking. Okay, when anyone asks you what networking is, you will just simply say that networking refers to the interconnected device, the devices that are connected to each other for sharing resources or for sharing data. Okay, now we will look at various kinds of networking if we consider the network in a large scale, then we can call it as man or WAN. Okay, and when we consider it as in a small scale, we will call it as LAN. Okay, so LAN means local area network. Okay, LAN means local area network. That means when the a particular when if we connect a router, if we connect a router first of all, let me discuss about LAN, MAN, WAN. Then we will discuss the networking devices. In that part, we will go through about the networking devices in depth. Okay, just focus on the LAN, MAN, and WAN connections as of now. Okay, so LAN means local network, local area network. Okay, when multiple devices are connected in a single area, in a small area. Okay, that is called the local area network. Okay. When the devices in different areas, when the multiple devices in two different areas are connected with each other, then it is called MAN, metropolitan area network. And WAN means when the multiple devices in different geographical areas are connected with each other, that is called WAN. We can call internet as WAN because the computing devices in different geographical areas are connected to each other. Okay, so these are the concepts of LAN, MAN, and WAN. Now we will go in depth of LAN, MAN, WAN again, but before that we will discuss the networking devices. What are the networking devices? Okay, so for that, let me present you my screen. You will get the popular networking devices there. You will get to know about that. Okay. 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 So we have already discussed the LAN, MAN, WAN. Okay. Now we will see the popular networking devices. So the popular networking devices are the router, switch, hub, firewall, bridge, modem, and repeater. So first we will look what router is. Router is a networking device that helps to route the data traffic. It manages the data traffic between various networks. When a computing device tries to send the data, okay, to a different to another computing device, so what router does, if that particular computing device is in another network, then it will deliver that packet, or it will deliver that data packets to that intended PC. Okay, it will basically select the routes, for the data traffics, okay, to reach the computing device that is in a different network, that is called the router. Now we will come to switch. What switch is? Switch is a switch is a networking device that works in layer 2. That means in data link layer. We have discussed router previously. So router works in network layer. We will go through the network layer, the data link layer in depth when we will see the OSI model. Okay, but before that, we will discuss about the networking devices. Just focus on the, working procedures of these networking devices. The switch is a layer 2 device. Okay, layer 2 is the data link layer. We will go through that, okay, later. So what switch does? Switch is very helpful when computing devices are trying to communicate in a single area. I mean, in a particular LAN. Okay? Switch handles. Switch manages the data traffics by using the MAC address. Okay? Switch manages the data traffic by using the MAC addresses. So we can connect multiple computing devices or end devices. You can call it end devices like computers, laptops, voice VoIP phones. Okay, we can connect all those end devices with the switch. So what switch does? Switch first takes the data frames from that particular device, and then it will decide in which direction should the data go. I mean, by using the MAC address, it will decide that what is the intended PC. Okay, what is the which one is the intended PC. Okay, but there is a catch here. Okay, when first time when first time switch gets the data from a computing device, it doesn't know that in which interface of that particular switch that computing device is connected to. Okay, so the switch doesn't know. First of all, the switch doesn't know. So when the computing device sends the data to that switch, the switch gets to know that yes, with my in this particular interface, PC1 is connected. Let's say I have named it as PC1 or laptop 1. So the switch understands that yes, in that particular interface, the PC1 is connected. Okay. So when PC1 sends the data, okay, so when PC1 sends the data, let's say PC1 is connected to the F1 interface of the switch. F1 means fast Ethernet. Okay, F1 means fast Ethernet. All right. Imagine that PC1 is connected to the F1 interface of that switch. The switch doesn't know first that in my F1 interface, PC1 is connected. Okay. When PC1 sends the data, switch 1 gets to know that yes, with my in my F1 F01 interface or fast Ethernet 01 interface, PC1 is connected. Then what it does, it will broadcast that frame. It will broadcast that frame. Okay, it will broadcast that frame, and when it will all those frames. I mean, when we are doing something, when we are broadcasting some frames, it will be received by all the PCs in that particular network, in that particular local area network. Okay, among those PCs, the intended PC which is expecting the data or the IP address. I mean, the if the IP address matches with the PC with a particular PC, then it will just receive the data and it will reply back. All other PCs in that particular LAN will discard the data. Okay, so switch operates in this way. Then comes hub. Okay, so hub is also like switch. Hub is also like the switch, but it doesn't have the memory. It doesn't have a memory. Switch have a memory. Switch have a MAC address table. So it knows to which interface the data should go, to which interface the data should be sent. Okay? The switch does know that. Switch has a brain, but hub doesn't have that. What hub does, hub just receives all the data from the computing devices and it will speed the data to other devices. For instance, if the hub is receiving all the data from multiple devices, imagine from multiple devices the hub is taking the data. Okay, receiving the data, and the hub then speed all the data. This hub will speed all the data from the from its other interfaces. Okay, let me just make you understand by a diagram, so I think it will be helpful for you. Okay, just let me open draw.io. Okay, so we will create a diagram here so that you will get to know these devices better. Okay, so this can be considered as a hub. Okay, let's take it as a hub. Okay, let's take it as a hub. So now what happens actually, for instance, multiple datas are trying to Okay, sorry. Okay, multiple datas are trying to enter in the hub. Okay, for instance, two computing devices are connected with this hub. For instance, two computing devices are connected with this hub. Okay. So this is the hub. Two computing devices are connected to each other. It will take the data from these two computing devices and it will spit that data from this interface. From this interface. It will spit all the data from these interfaces. Okay. It will. It is unable. Hub is unable to differentiate anything. Okay. Hub is unable to differentiate anything. Okay. Let's go back to the PPT again. Okay. Hub cannot differentiate among the intended devices. Hub just takes all the data and spits all the data. After that comes the firewall. Firewall is for the security purposes. Okay. Firewall is for the security purposes. That means if we install a firewall, okay, then what it does, it will restrict the flow of the traffic. Okay, it will restrict the flow of the traffic by using the source IP address or destination IP address, source port number or destination port number, or even the source protocol, destination protocol, anything. I mean, not source protocol or destination protocol, about the protocols. Okay, just you can tell that on the basis of the protocols, on the basis of the protocols, on the basis of the port numbers, on the basis of the IP addresses, everything. Okay, the firewall can, I mean, restrict the data traffic. Okay, even if we make ACL, okay, if we can consider ACLs as the firewalls in a router. If we configure access control lists in the router, it will act as a firewall to a certain extent. Okay, after that comes bridge. So what bridge is? Bridge actually connects multiple small LANs with a bigger LAN. Okay, bridge connects multiple small LANs with a larger LAN. Okay? It acts as the connecting device. Okay? After that comes the modem. So what modem is? Modem means modulator and demodulator. What it does, it modulates and demodulates the signal. That means when we can't communicate, we can't connect to the internet without a modem. Okay, we can't connect to the internet without a modem. Why? Because first it takes the digital signals from our computer. Okay, what it does after that, it will convert that digital signal into an analog signal. Okay, that analog signal is important because the digital signals can't travel in the internet. Okay, we need analog signals for that, and modem does it for that. When we receive analog signals, it converts that analog signal into digital signals again and sends it to our computer. Okay, so modem is a very crucial part of our networking. Okay. After that comes the repeater. So what repeater is actually? Repeater means it is a self-explanatory term because it repeats the signal. It will amplify your signal. For instance, let's go to this part again and just try to search repeater here. Okay, we have yeah, we have got a repeater. Okay, we have got a repeater. What it does, it will just take your signal, it will just take your signal and it will amplify it. It will amplify it. Okay. will amplify that particular signal. Okay. For instance, if the network is large, for instance, if the two devices are connected to each other with a large wire, okay, so when the signal travels due to some phenomena, the signal gets weakened. Okay, so to strengthen that signal, repeater is necessary, because if we receive the weak signals, then the quality of the data will be degraded. The quality of the data will be degraded, right? If we receive the weak signals. That is why it is necessary to amplify that signal. Repeater doesn't change that signal. Repeater only amplifies that signal. Okay? It will amplify that signal and it will send to the intended computing device. Okay? Repeater does that. In repeater, the actual function of the repeater is this. To repeat and to amplify the signals. Okay? To amplify the signals in such a way that the quality of the signals doesn't get degraded. Okay? After that, we will come to ISOAH model. Okay? We will come to ISOAH models, open systems interconnection. So what ISOAH model is? So ISOAH model is kind of a, it doesn't have a physical existence. Okay? It is made to make the to understand the data flow, the encapsulation, data encapsulation process, data de-encapsulation process, data flow, how the protocols communicate with each other. This particular models helps us to understand that, and it is categorized in 7 different layers, and the topmost layer, application layer, resides. Okay. After that, the presentation layer, as you can see in that particular diagram, presentation layer, session layer, transport layer, network layer, data link layer, and then physical layer. So what are the functions of these different layers? Okay, what are the functions of these different layers? First of all, let's consider the application layer. Okay, application layer means in that particular layer, the applications, for instance, the software applications that we use every day. Okay, software applications that we use every day functions in that particular application layer. Okay, different protocols like HTTP, HTTPS, okay, FTP, everything works in that particular application layer. After that comes the presentation layer. So what presentation layer do? What presentation layer actually does? Okay, so presentation layer, first of all, the task of the presentation layer is to take the data from the application layer and transform it in the network. In such a form that it can be transmitted through network layer. Okay, and there is another task of presentation layer. It encrypts and decrypts the data. Okay, presentation layer does both encryption and decryption. Okay, during the encryption and decryption process, during the encryption process, it compresses that data. It compresses that data. Okay. That is the task of the presentation layer. After that comes the session layer. So what session layer actually does? Session layer, it is a self-explanatory term. It creates session. That means it creates connection. Okay, it creates connections between two computing devices. It creates connections between two computing devices. A session creates in the session layer. The session layer doesn't have any physical existence. We just are defining it to understand at which layer the session gets created. Okay, at which layer the session gets created. Okay, it establishes the connection and it helps to send and receive the data packets through that particular connection. Okay, the information or data through that particular session. If we can send any command through that particular session layer, we can receive any command through that particular session layer. Okay, After that comes the transport layer. Okay. So what is the transport layer? Transport layer is the fourth layer. Okay. Transport layer is the fourth layer of the OSI model. What it does actually, it does a flow control first of all. Okay. It does a flow control, and besides that, what it does, it segments the packet. It breaks the packets into various segments. Okay. It breaks the packets in various segments. It assigns some sequence number with each of that packet. So when we will receive that packets, when we will receive that segments, basically in transport layer, we will call the data as segments. We will call the data as segments in the transport layer. Okay. So transport layer, what in that particular transport layer, what it does, it assigns the sequence number in each of the data packets. When it is breaking up the data, it is breaking up the data in various, segments, in different segments. Okay, and in each segment, in each data packet, it assigns a particular sequence number. So when the data is received, the data doesn't get disoriented or the distorted. Okay, so this is the task of the transport layer. After that comes the network layer. Okay, in that particular network layer, router works, and the concept of IP address comes in this particular network layer. Okay. So what is the task of the network layer? The task of the network layer is to route the data traffic, is to select the path, is to select the best path from the source to destination. Okay. In this layer, it gets decided that from which path the data should travel. Okay. This is the network path. After that comes the data link layer. The data link layer is the second layer. If we count it from the bottom, then it is the second layer. Okay, and if we count it from the top, it is the sixth layer. Okay, so what data link layer is, in that particular data link layer, switch actually works. Switch actually works in the data link layer. Okay, switch can work in both, network layer and data link layer. Multi-layer switches can work in both network layer and data link layer, but as of now, just consider that switch works in the data link layer. We will not go through multi-layer switch as of now. We will just stick to the layer 2 switches. Okay, so the switches work in data link layer, and in the data link layer, MAC addresses are required. When we are sending the data, we need the MAC addresses. When we are sending the data in the data link layer, we need MAC addresses to identify the devices. Okay. Okay, and another thing that I need to mention, that we will call the data as packets in the network layer, and we will call the data as frames in the data link layer. So in transport layer, we will call the data as segments. In the network layer, we will call the data as packets. In the data link layer, we will call the data as frames. Okay. After that comes the last layer, that is the physical layer. Physical layer means it it can be wired. It defines the medium of communication, like the wired mediums or wireless mediums. In the wired mediums, we can use Ethernet cables, fiber optic cables, and in the wireless, if we consider it as the wireless medium, then the radio waves can be considered. Okay. So these all are the all the layers are in the OSI model, and cumulatively we will call all the data. Okay, all the data we will call that PDU. Okay, protocol data units. We will call the data in all these layers as PDU, protocol data units. Okay. After that, we will go through the TCP/IP model. So what is the meaning of TCP/IP? First of all, TCP/IP means transmission control protocol and internet protocol. Okay, it is categorized in 4 parts. It is categorized in 4 parts. If we try to differentiate between the OSI layer, OSI model and the TCP/IP model, then as you can see, Here, application, presentation, and session, those three layers are combined in a single layer. These three layers are merged in a single layer, and the name of that particular layer is the application layer. Okay. As I have already discussed, HTTP, TLS, DNS, everything runs on in the application layer. The transport layer, I mean, the TCP UDP protocols runs on the transport layer. Okay, this transport layer is same as the transport layer as the OSI model. Okay, there is no difference between that. The working procedure is same. Okay, the working procedure is same, and then the network layer in the OSI model we will call the third layer as the network layer, but in TCP/IP model we will call it as the internet layer. Okay, we will call it as the internet layer. In the internet layer, IPv4 addresses and IPv6 addresses work. Okay, IPv4 means Internet Protocol version 4, Internet Protocol version 6. We will go through about the IP addresses and in a while. Okay, and after that, both these layers, the data link layers and the physical layers, are combined in the network access layer. Both these layers are combined in a single layer that is called the network access layer. Okay. Okay, in this network access layer, both the hardware and the MAC addresses will work. Both the hardware, that means the Ethernet cable, fiber optic cable, radio waves, if we consider the wireless medium. Okay, it will work in the network access layer, as well as the MAC addresses. The communication by using the MAC addresses will also be implemented in that particular layer. Okay. After that, we will go through the MAC address. Okay. So what MAC address is? MAC address means media access control. Okay, the length of the MAC address is 48 bits. The length of the MAC address is 48 bits. Why the length of the MAC address is 48 bits? As we can see the representation here. Okay, we have separated these digits by using a colon. Okay. Okay, so to make you understand the MAC addresses better, let me share my screen again. Let me, open the notepad so that I can make you understand. Okay. Okay. In the notepad, okay, first of all, we can represent the MAC address like this. We can, denote the MAC addresses. We can represent the MAC addresses in three different ways. Okay. Just let me show you how we can do that. Okay, here all the digits are hexadecimal digit. This 0 is a hexadecimal digit, this particular 0 is a hexadecimal digit. One hexadecimal digit will contain 4 binary bits. That means this 0 will contain 4 binary bits. Again, this 0 will contain 4 binary bits. So in total there will be 8 bits, and there are 6 octets. So 8 into 6, the calculation is 48 bits. That's why the length of the MAC address is 48. That's why the length of the MAC address is 48. Okay. Now, as I have told you that I will show you how the MAC addresses can be represented. So this is one way. Another way, we will just copy it, paste it over here, and we will use the colons here. This is colon separated MAC address. Okay. Okay, we can represent it like that. Otherwise, what we can do here, we will just do it like that. Okay, we can represent, just let me make it little bigger. Okay, so as we can see that we can do it by three ways. We can represent the MAC address in three different ways: by using the hyphen, by using the colon, and by using the periods. Okay. Okay. So all these are hexadecimal digit. We can there are in total. Okay. In total, there are here there is a okay, total there are total almost there is uh, 1 2 3 4 5 6 7 8 9 10 12. Okay, yeah, the calculation is right. There are 12 hexadecimal digits is there. Okay, 12 hexadecimal digits will be in a particular MAC address. Okay, 12 hexadecimal digits will be in a particular MAC address. We can call the MAC address as the burnt in address, BIA. Why we can call it as a burnt in address? Because it is burnt in our network interface card. We can't change it. Okay, during the manufacturing time, the manufacturer has burned the particular MAC address in our NIC card, network interface card. Okay, now MAC address can be categorized in two parts. One is organizationally unique identifier and another is the extension identifier. These first three octets, okay, these first three octets, let me write it down here. These first two octets is first three octets are called the OUI, organizationally unique identifier. Okay, that is called organizationally unique identifier. Okay, and then these last three octets is the extension identifier. These first three octets, okay, these 6 hexadecimal digits are unique to the device manufacturer. Okay, device manufacturer, that means the person who is making the device. Okay, the person who is making the device. And the last three octets, last 6 actually hexadecimal digits, last 3 octets can be categorized as extension identifier. Okay, these 3 octets are assigned by the network admins. Okay, so as I have already discussed, MAC addresses are used in data link layer of the OSI model. Okay, MAC addresses are used in the data link layer of the OSI model. Okay. After that, we will go through the IPv4 address. The length of the IPv4 address is of 32 bits. Why? Why the length of the IPv4 address is 32 bits? We have already represented the IPv4 address in this way. Okay, so let me discuss it. I'm removing all these things here and I'm writing 192.168.1.1. So this is a IPv4 address. This is a IPv4 address. Okay, here this 192 is in decimal, right? I mean, it's this is in the decimal format. We need to convert it in the binary. Okay, we need to convert it in the binary. So how can we do that? How can we convert 192 in the binary form? Okay, so for that, let me open the paint. Okay, so if we just divide that 192 by 2, okay, if we divide 192 by 2, so that will be 96 and 0. We need to divide it like that. Okay, so that we will gain the actual result, how it can be converted into the binary. Okay, we have to do it again and again until we get the 0. Okay, we have to do it. So this is the from decimal to binary conversion. This method is called as the decimal to binary conversion. Okay, If you want to convert a decimal number into the binary number, you have to do it in this particular way. And if you want to convert the hexadecimal number in the binary number, then one hexadecimal number contains the 4 binary digits, as I have shown you already. Okay. Okay, so just this is 3 and we are getting remainder as 0, and after that if we divide it as 2 1, this is 1. Okay, we can divide this 1. If we want, we can divide this 1, we will get the result as 0 and the remainder as 1. And if we do not want to do that, just do not need to do that, and we will count it from the bottom to top. So the binary representation of 192 will be 1 1 and 6 6 6 6 6 6 6. Okay, 1 1 3 and then again 3 zeros. Okay, 6 zeros, double 1 and 6 zeros. Okay, 192 can be represented as in this binary format. Okay, double 1 and 6 zeros. So as you can see here, it contains 4 and 4, total 8. Okay, in total it contains total 8 binary digits. So there are 4 octets. Okay, so there are 4 octets. So in total 8 into 4 will be 32. Okay, that's why the length of the IPv4 address is 32 bits. That's why the length of the IPv4 address is 32 bits, is of 32 bits. If we want to represent this 1 as the binary, then we will do it in this particular way. 4 zeros, after that 0 0 0 1. Okay, in such a way. All right. Okay, let's get back to the slides again. Okay, so we can categorize the IPv4 addresses in 5 parts: class A, class B, class C, class D, and class DE. Okay, among these 5 classes, we will only use class A, class B, and class C. Class E is for the research is reserved, and class D is for the multicast addresses. We will go through the multicast addresses later, not in this session, in another session maybe. So class A address. So what will be the range of the class A IP address? Okay, before going through that the ranges, let me discuss the concept of public IP addresses first. So what are the public IP addresses? Okay, the public IP addresses actually are used to communicate with the internet. Without a public IPv4 address, we can't communicate with the internet. Okay, the IP addresses that we can see in our devices, that is our private IP addresses. We can't use private IP addresses when we are going to access the internet. To access the internet, we do need public IPv4 addresses. Okay, the public IPv4 addresses are assigned by the ISPs. For that particular IPv4 address, we pay to our ISPs. Okay, so what are the range of the public IP addresses? The range of public IP addresses, the class A is 1 to 127. Okay, from 1 to 127. After that, the range of the class B addresses from 128 to 191. Okay, that means, just let me write it properly. For class A, the range will be 1.0.0.0 to 127.255.255.255. In the same way, we will define class B, and that will be from 128.0.0.0 to 191.255.255.255. After that, for class C, 192.0.0.0 to 192.255.255.255. Okay, for class D, this is not actually required, but still I'm showing you guys. Sorry, I have made a mistake here. It will be 223. Okay, 223. So 224.0.0.0 and 239.255.255.255, and after that class E address 240.0.0.0 to 255.255.255.255. Okay, these are the range of the public IPv4 addresses. These are the range of the public IPv4 addresses. Then we will go through the private IPv4 addresses. Private IPv4 addresses are assigned by the routers. Okay, private IPv4 addresses are assigned by the routers, network routers. We can't communicate with the internet, as I have told you before. We can't communicate to the internet by using the private IPv4 addresses. We can't do that. Okay, the ranges of private IPv4 addresses are different. The ranges of private IPv4 addresses are different. For instance, for class A, as we can see here, for the class A, the range is from 10.0.0.0 to 10.255.255.255. For class B, it's 172.16.0.0 to 172.31.255.255. And for class C, it's 192.168.0.0 to 192.168.255.255. So as you can see, all the ranges are different for the private IPv4 addresses. Okay, so we have received a basic idea about the IPv4 addresses, MAC addresses, and the fundamentals of networking. Okay, we have gone through a lot of theory. Now we will see the packet tracer. So what packet tracer is? Packet tracer is the simulation software in which we can simulate some networking devices. We can simulate some networking devices. Okay, so let's open the packet tracer. Okay, so we have received the interface of the packet tracer on which we will perform the networking tasks. So let's select the networking devices first. As you can see here, can we zoom it? I think it will. Okay, just let me try to zoom it. Okay, all right. I think. Okay, yeah, zoom in. Okay, we need to first, uh, place the devices. After that, we will zoom it. Okay. Okay. So first we are taking routers. This is the router. Okay, this is the router. So we will select 2811 router here. Okay, we have made it. Let's zoom out. Okay, let's zoom out. Okay, I think it is okay now. Okay, all right, and then we will select the switch 2960. Okay, we will select the 2960 switch. This is a switch, this is the router, and we will select two PCs here. Okay, another PC we will select. After that, what we will do, we will choose copper straight through cable. When copper straight through cable is used, copper straight through cables can be used to connect two different devices, two different networking devices. And when we will use copper crossover cable, we will use copper crossover cable when we will connect same networking devices. The I mean, when we are connecting same networking devices, we are using copper crossover cable, and when we are connecting two different networking devices, we will use straight through cable. Okay, let me draw the wire. Okay, after that we will configure this router. So this is the command line interface. So this is the command line interface of the router. From this interface, we can configure the router. From this interface, we can configure the router. Okay. So let me type no here. After that, we have entered the user exec mode. Okay. We have entered the user exec mode. Okay. In the user exec mode, we can't configure the router. We just can run a certain commands. For like, we can ping the routers, we can ping different routers, we can use the traceart command. Okay, that means to uh, find how the network the data is going through hops. Okay, through routers. Okay, hops means the routers, the count of the routers, how the data is traveling through the routers. Okay, so to go from the to change the user exec mode into the privilege exec mode, we will type enable command. Okay, the short form is N and the full form is enable. We have entered in the privilege exec mode. Okay, in the privilege exec mode, we can't configure the router. We can only see the configurations. We can only see the configurations that we have made. Okay, so as we need to configure the router, we will change this privilege exec mode into the global configuration mode. In the global configuration mode, what we can do in the global configuration mode, we can communicate, we can configure the router. Okay, we can configure the router. Okay, so the command is configure terminal. Okay, configure terminal. In short, it can be written as conf t. Okay, in short, it can be written as, just let me zoom it. Is it possible? I think, just let me try. No, I think it is not possible to zoom this. Okay, so configure terminal. Okay, let me write it in full. Configure terminal. We have entered the global configuration mode. In the global configuration mode, we can assign the IP address in a particular interface of a router. In the particular interface of the router. Okay, that means this interface. What is the name of this interface? That is FA01. That is Fast Ethernet 01. Okay. So let me write it for if interface FA01, and we can assign the IP address here. So to assign the IP address, we have entered into the interface configuration mode now. So we need to enter the IP address here. So to assign the IP address here, we need to type the command IP address, and we can assign the IP address. We are assigning a class C IP address here. Okay, for instance 192.168.1.1. okay, I think we also need to give the subnet mask here. Okay, what subnet mask is? Subnet mask is used to differentiate which portion of an IP address is the network portion and which portion is the host portion. Okay, it will help to determine the network portion and the host portion of an IP address. Okay, so this is the subnet IP. Okay, so what is the default subnet? Okay, let me discuss the default subnets. For class A, for class A, the default subnet mask will be /8. That means 255.0.0.0. For class B, it's 16. That means 255.255.0.0. We will go through the details of subnet mask when we will see the subnetting part of networking. Okay, we will go in depth in the next season, okay, about the subnetting. 255.255.0. Okay, so this is the default subnet mask for the class C. 255.255.255.250 three 255s and 0. So what does it mean? That means in this particular IP address 192.168.1.1, these 3 octets will be the network portion, okay, and this last portion, this last octet will be the host portion. Okay, okay, so let us just assign the IP address here. We have assigned the IP address, and after that we will use the no shutdown command to make this interface up. Okay, we have changed the interface to the up. Okay, we have entered interface. Okay, okay, some problems, a problem has happened here. Okay, this is F00 actually, so we need to assign this with F00. Okay, let me change it to F01 so that, okay, just let me delete it. Let me just delete this portion. Okay, and after that fast Ethernet 1 to fast Ethernet 1. Okay, okay, so as you can see, it is up. So we can assign the IP addresses in the PCs from here. 192.168.1.2. The default subnet mask is 255.255.0.3 and then 0, and the default gateway is the IP address of this interface of the router. Okay, and then just write it here. This will be 192.168.1.3, 255.255 and 192.168.1.1. okay, and we can ping it from here. Okay, we can ping it from here, from the command prompt, ping 192.168.1.3. okay, so as we can see that it is pinging, so the connection is completed. Okay guys, so that is all for today for this season. Okay, so thank you, and I think we will, go through, we will learn various other topics in the next season. I think you have all, guys, you all have enjoyed the session. Okay, and just try, we have, so in overall what we have gathered today, we have gathered the network, or the ideas of network fundamentals. Okay, how the OSI model works, how the TCP IP model works, what is the definition of networking. Okay, what actually, how the data travels through the internet. Okay, and how we can refer the OSI model or TCP IP model during the data communication. We have gone through that. Besides that, we have learned the fundamentals of MAC address and IPv4 addresses. In the next season, we will go through the IPv6 addresses also. Okay, we have gone through the IPv4 addresses. We will go through the subnet masks and subnetting, the concept of subnetting, and IPv6 addresses in the next season. I hope guys you all have enjoyed this session, this network fundamentals, IP address and MAC address session. Thank you guys. It was really, I'm really grateful to guide you guys. At the same time, I have also learned from you guys. Thank you. Bye.